Hello, I'm Alexis DeJarnette with Axiom Space, and thank you for joining us today. We're excited to share an update on the important microgravity research, experiments, and technology demonstrations that will occur during Axiom Space's Ax-3 mission, which is targeted to launch no earlier than January 2024. Today, we will hear brief remarks from Axiom Space's Chief Scientist and Director of In-Space Manufacturing, as well as leaders representing the European nations on the Ax-3 mission. I'm excited to introduce today's speakers. To start off, let me introduce our Axiom Space team. We have Dr. Lucy Lowe, our Chief Scientist, and Jana Studemeyer, our Director of In-Space Manufacturing. Now I would like to introduce our European representatives. We have Colonel Antonaucci of the Italian Air Force, Dr. Barbara Negri from the Italian Space Agency, Omer Atash with TÜBİTAK Space Technologies Research Institute, Hassan Yural of the Turkish Space Agency, Dr. Christine Danenberg with the Swedish National Space Agency, and finally, Dr. Julia Weiss from the European Space Agency. We look forward to this opportunity to focus on Ax-3 and to provide an overview of the important work that will be done on the first all-European commercial astronaut mission to the International Space Station. In a moment, I will turn it over to our speakers for their opening remarks. Following remarks, we'll open it up for reporters to ask questions. If you'd like to ask a question, please submit your questions in the chat to the moderator or use the raise your hand feature. When you are called upon, please state your name, affiliation, and to whom you'd like to direct your question to. We'll begin with Lucy's opening remarks. Thank you.
Thank you so much, Alexis, and we are delighted to welcome all of our fantastic panelists and speakers and also all of our press joining us today. We're looking forward to hearing some of your questions. So we are delighted to welcome everyone to this Ax-3 Science Press Conference, where we can give you a flavour of some of the exciting research that's going to be taking place on the Ax-3 mission. Now, as Alexis mentioned, this mission is the first all-European mission with 4 European astronauts representing their countries as well as the European Space Agency. So we're excited to be building on the successes of Ax-2 by continuing to expand the global microgravity research community and enabling new researchers from many countries to access microgravity for sometimes the first time. So Italy is bringing a very strong research portfolio from the Italian Space Agency, the Italian Air Force, and also a number of commercial Italian companies looking to leverage microgravity for product testing and development. Their experiments will consist of various different projects investigating and mitigating the physiological effects of spaceflight on humans, as well as a strong focus on using microgravity to understand biological changes related to health and disease. And then there are also some commercial activities related to improved cuisine, as well as materials development in space for long-term microgravity habitation. The Turkish portfolio is led by the Scientific and Technical Research Council of Türkiye, and it has a very strong focus on advanced development of novel hardware and capabilities, which is building on Türkiye's success with satellite development to increase and improve their goals as a spacefaring nation. Many of these projects are going to be adopting quite advanced scientific methodologies, such as metabolomics or gene editing, to understand the impact of spaceflight on plants and humans, for example. This is truly a national effort with researchers across Türkiye contributing to the space research portfolio, as well as a very strong educational and outreach aspect to inspire children and students across Türkiye. And also, we are delighted to welcome Sweden and the European Space Agency to join us on the Ax-3 mission. Obviously, ESA has an extremely strong and well-established history in spaceflight and space research, and the ESA portfolio on Ax-3 is going to continue to build on ESA's mission to bring value to the citizens of Europe and the world, and also increase and improve Europe's space capabilities. The portfolio is going to carry on many important and ongoing projects that ESA has been running for a number of years that are going to continue to develop advanced technologies for application on Earth and also really enable long-term space exploration and habitation. There'll also be continued work on some very interesting and exciting fundamental scientific research through the ESA portfolio. But not only is this mission heavily supported by international governments, we are again working with a number of academic and commercial partners, both in flight and on the ground, to help us understand human health and performance in space, as well as test new commercial products and also learn more about things like weather phenomena here on Earth. So as with Ax-2, there continues to be a strong focus on cancer research and stem cells related to in-space manufacturing, and it reflects Axiom's leading the way in helping develop a robust low Earth orbit economy. But I'm going to hand over to my colleague, Jana Studemeyer, our Director of In-Space Manufacturing, who is going to tell us some more about some of these advances that are being enabled on the Ax-3 mission. So Jana, over to you.
Thanks, Lucy. Exciting science on this mission, and so pleased to see it come together the way that it has. I'm pleased to share brief highlights on the work we're doing with our partners on cancer and neurodegenerative diseases in support of future commercial applications. The ongoing Cancer and Leo project from the Sanford Stem Cell Institute is studying tumor organoids in microgravity with the aim of identifying early warning signs of cancer for prediction and prevention of this disease and accelerating opportunities for the development of new cancer therapies for patients here on Earth. The Cosmic Brain Organoid project from the National Stem Cell Foundation is studying brain organoids derived from the stem cells of patients with Parkinson's disease and primary progressive multiple sclerosis to uncover cellular pathways that help better understand and treat neurodegenerative diseases on Earth. Through these partnerships, we're working to create diverse and robust new markets in the commercial space economy that will generate significant economic and social benefits around the world. Back to you, Alexis.
Thank you, Jana. We now have Colonel Domenico Antonacci from the Italian Air Force.
Good morning and good afternoon, everyone. I'm thrilled together with you today to delve into the first set of Italian research projects we are taking on the S3 mission in a flourishing partnership under this new paradigm between some Italian space pioneers and Axiom. Let me say that Ax-3 embodies the spirit of international cooperation and serves as a platform for displaying Italy's rich heritage in space science and technology, demonstrating the nation's commitment to innovation at its vanguard position in global space industry. Similarly, the Italian Air Force journey into space is fueled by firm scientific research program, which aims to elevate our grasp of aerospace environment. As an Air Force, we are contributing to Ax-3 with our expertise in space defense, in collaboration with the Italian space industry as well. Additionally, in conjunction with the Italian University, our medical team of flight surgeons has dedicated unwavering effort to integrate human subject research into the mission. As a result, our experiments span diverse fields. In the field, for example, in the field of technology and capability development, a few years ago, the Air Force, in collaboration with the Italian space industry and the universities, has developed a cutting-edge software system that provides a comprehensive catalog of space objects and advanced algorithms for analyzing space-related events such as collisions. That same command and control software is at the heart of our Air Force Space Situational Awareness Center, which serves as a dual-use facility, and it's one of the main civilian European hubs for evaluating the re-entry and also the fragmentation of space objects. With Ax-3, we will be testing our software system on the ISS. This trial will serve as a proof of concept, demonstrating how astronauts could potentially conduct near real-time collision analysis with minimal support from ground segments or even autonomously. And now moving to the aerospace medicine sector, in partnership with the Italian academic institutions, we are conducting an extensive medical investigation on the Ax-3 crew that involves ultrasound and blood sample collection to assess vessel's functionality. Through a complex integration process, we successfully brought the study to the ISS. Long-term follow-ups on Earth will be conducted to gain a deeper understanding of the interaction between space environment and human physiology. Building upon our previous research on aerospace effects on fighter pilots, this study aims to shed light on the role of the endothelial dysfunction as a potential precursor to cardiovascular disease. and an indication of arterial health during extended space mission. The Italian Air Force is very proud to be part of Ax-3 mission and to participate with you all to get ready for this different opportunity. With that, I will hand it back to the moderator, and thank you.
Thank you, Colonel. We now have Dr. Barbara Negri of the Italian Space Agency.
Hi, thank you. Good morning, everyone. Italian Space Agency are delighted to participate in Ax-3 mission, as this marks the first collaboration between us and a private operator for research on the International Space Station. Our human spaceflight program was initiated over 20 years ago. To date, ASI has collaborated with both NASA and ESA, conducting over 73 experiments on the ISS, with a focus of human research, biology and biotechnology, and physical science. For the Ax-3 mission, ASI will conduct 4 experiments in orbit, 3 of which focus on cell biology and 1 on physics. Additionally, 2 ground experiments are planned involving pre- and post-flight biological sampling on a private astronaut. 2 of the cell biology experiments to be conducted on the ISS are beta amyloid aggregation and Prometeo 2. The result from this research will enhance our understanding of neurodegenerative disease, which is crucial for developing new therapies for age-related pathologies on Earth. Specifically, beta amyloid aggregation investigates how microgravity affects the aggregation of amyloid beta AB proteins, which are implicated in neurodegenerative disease, such as Alzheimer's. Similarly, Prometeo 2 aims to demonstrate how specific antioxidant nanoparticles can counteract the oxidative stress induced by space environments on neuronal cells. This research is important for developing countermeasures for future spaceflight mission and therapeutic tool for treating neurodegenerative disease on Earth. The third biology experiment, Orion, will provide new insights into how microgravity affects women's fertility, particularly ovarian functions. This research investigates the impact of microgravity on bovine ovarian cells and the mechanism of hormone production and modulation. The finding could potentially improve the success of fertility treatments on Earth. The last experiment, LIDAL, addresses a critical aspect on human space exploration, exposure to the radiation environment in space. LIDAL is designed to provide the first real-time radiation risk meter on the ISS, keeping the crew informed about the risk from cosmic radiation and space weather events. The ground experiment, astronauts and NAPS, will analyze biological samples from the private astronaut before and after Ax-3 missions. Astronauts aim to identify early biomarker signature for autonomous monitoring of Earth during spaceflight. This project may lead to the development of point-of-care devices for non-invasive diagnostics and prognosis of diseases, which can also be used on Earth. NUT will profile the alteration of specific molecular markers induced by stress condition in short-duration space mission and compare them to the effect observed in a submarine missions. This approach will enable us to differentiate the effect induced by microgravity and cosmic rays from those caused by confinement, isolation, and psychological stress. Back to Alexis.
Thank you so much. We now have Omar Atash with TÜBİTAK Space Technologies Research Institute. Over to you.
Thank you, Alexis. Good morning and good evening the European partners. I'm very excited to be here and to participate on Ax-3 mission, as it's our first mission for our sustainable microgravity research program. The human space flight mission, introduced by Turkish Space Agency under the National Space Program, with enabling the Turkish scientists to access microgravity to conduct research for the benefit of humanity. On Ax-3 mission, we engaged Turkish scientists to develop their experiment and conduct during the 2 weeks too short stay mission. Our portfolio consists of experiments from universities, research institutes, and centers, and all of this research funded by Turkish Space Agency. The experiment consists of projects in metallurgy, biology, biotechnology, human studies, technology demonstration, and physical science. With regarding to metallurgy, the researchers from Marmara Research Center will investigate the thermophysical properties of alloy by bringing the sample at melting point to measure the density, surface tension, and viscosity of the alloy. Then let it cool down to recrystallize to compare the alloy production under G and microgravity. When we look at the biology, the scientists from Ege University will study the vital behavior and biological properties of plant species that have adapted the harsh condition on Earth, which are called extremophyte under microgravity situation. The plant that scientists are going to study is called Schrankula parvula. It can survive very salty soil. This plant can remove salt from soil and water, so it can contribute to plant studies on Mars in future. Also, Yıldız Teknik University will study some gene expression by using CRISPR technique, which is one of the gene editing techniques in microbiology. With regarding the technology demonstration, Boğaziçi University, Istanbul University, TÜBİTAK UZAY, and Marmara Research Center collaborate to demonstrate hybrid life support system for converting carbon dioxide to oxygen in closed environment. In this study, different microalgae will be used to compare their performance in converting carbon dioxide to oxygen and also analyzing the adaptation in microgravity. As human research led by Hacettepe, Ankara, and Üsküdar universities, the amic analysis, microgravity-related genes, and myeloid cells will be studied. On the short-term space mission, by collecting blood, urine, and saliva from the astronauts during flight, post-flight, and pre-flight. On the other hand, Nişantaşı and Haliç universities developed an AI-based application to analyze audio of cough, breathe, and some sound data to predict lung and cardiovascular disease under microgravity. The research from TÜBİTAK and Middle East Technical University will investigate the effect of microgravity of two-phase mixing between solids, particles, and gaseous medium in stationary volume to validate knowledge on formation of homogeneous mixture on metal particles and a gaseous oxidant. This will help us to ensure efficient combustion mixture in hybrid propulsion system. And also scientists for the future, a group of middle school students gathered together in a study of STEM experiment. They will analyze the microbiology of closed environment and test the sanitizer effect of propolis, which is a mixture of pollen and beeswax collected by bees from plants and trees. And lastly, TÜBİTAK UZAY will investigate the on-orbit soldering on printing circuit boards, and the integration of this long-term study started and will be conducted as part of sustainable microgravity research program. Thank you. Back to you, Alexis.
Thank you, Ömer. We now have Hassan Yural of the Turkish Space Agency.
Good morning and good afternoon, everyone. We are, as TUA, we are very excited to be part of this multinational Ax-3 mission. And as my colleague, Mr. Ömer, explained our science mission in detail, I'm not going to take much of your time. 3 years ago, Turkish Space Agency announced the national space program, and one of our goals in the space program is sending an astronaut to space tasked with the important science objectives. As this is our first manned space and space mission, and due to this year being our Republic's 100th anniversary, this mission is the utmost important for us. We had a lot of application for our mission, and it was difficult to choose between valuable experiments. So we had to balance between our national long-term strategic goals and the potential value for our space missions. For example, as my colleague Mr. Ömer explained, our materials research, we aim to research the next generation of alloys for both space and Earth applications. The data we collect from the microalgae experiments will help us to better understand these microalgae in order to be more carbon efficient on the Earth, and also research more next generation bioregenerative life support system for future space missions. Also, some of the microalgae specimens we used in these experiments were a result of our own Arctic expeditions. So these microalgae will have an interesting journey from Arctic to space. Our astronaut will not be just taking experiments to space, but the hopes and dreams of our entire nation, be it civilian or researchers alike. Thank you. Back to you, Alexis.
Thank you, Hassan. Now we have Christine Danenberg with the Swedish National Space Agency.
Thank you very much, Alexis, and good morning and good afternoon, everyone. I hope you can hear me. I'm really glad to be here at the press conference and to tell a little about science which will be done by our Swedish astronaut, Marcus Wandt. And as you also know, that Marcus Wandt is not just Swedish astronaut, but he's also ESA project astronaut, and he was selected as ESA reserve astronaut a year ago. So it's really a fast track. He will be flying in January, just selected last November. And as ESA project astronaut, he will participate in around 20 European experiments. And already estimated time allocation is about 80 hours. And actually, my colleague Julia Weiss from ESA will tell more about these experiments. But I will just briefly tell about 2 Swedish experiments that we have selected for his flight. And also, the selection was done just in May, and it has been really fast-tracked. So it's really exciting to not just to Marcus, but also to all of us. And we have 2 experiments, as I mentioned. So one experiment is multidisciplinary. It's called orbital architecture, and it's not about orbits, but it's about how environment at ISS, kind of architectural environment, interior affects cognitive performance and well-being of the astronaut and stress level. And this is really important aspect, not just on ISS, but also in different environments like isolated environments or also in our office space. Because depending on how well environment is organized and designed and how well astronaut or person perceives the environment, so kind of well-being and performance and all different kind of cognitive features are affected by this environment. And also, so what will be measured actually, brain activity. And also astronaut will answer a questionnaire with many questions at different occasions. And the results and the outcome will also be compared with different studies on Earth in extreme environments. And hopefully, if everything works well, we hope that it will also be implemented in the future at the International Space Station. So this is very new, actually. And people involved in the experiments, they never had any space experience before. So actually they're coming from ergonomy and kind of more like a medical part. So it's really interesting how space engages people from non-space fields. And also I think it will be results and also the whole story will be of great interest for general public. And not least to architects, I suppose, who design our workspaces and our environment. So this is briefly about this first experiment. And the second experiment is a life sciences experiment. And I heard from previous speakers, so life sciences is one of kind of important topics and topics in focus for this Axiom mission. And it deals with neural stem cells. I believe there were some other experiments on stem cells. And this is also very interesting. PI has done microgravity experiments on sounding rockets launched from Esrange in northern Sweden. And when you launch experiments from northern Sweden on suborbitals or sounding rockets, the exposure to microgravity is just six minutes, which is quite short. But what PI discovered already after 6 minutes, there's some delayed effect in these stem cells, actually. So when one measures how they perform after microgravity exposure, one notices that cells grow faster and also they divide faster. So this is really interesting effect or interesting outcomes that needs to be studied further. And for the Axiom 3 mission, so we have selected this experiment to be flown to ISS. So which is really interesting. From 6 minutes, it will be exposed during almost 14 days or 12 days of microgravity, and then it will be studied by science teams. And all the results are quite new, of course, and further studies are needed also on ground. So this is really exciting. We look forward to the mission and to all the experiments. And as I mentioned, there are many more experiments which are provided by ESA and European agencies, which Marcus Wandt will perform. So my colleague Julia will tell later about them. But now back to Alexis.
Thank you so much, Christine. We now have Julia Weiss with the European Space Agency.
Yes. Hello. So also ESA is really excited about this mission, and for us the collaboration with Axiom Space, with the Swedish National Space Agency and SpaceX is really a great opportunity to broaden our access to space. So, and especially to the ISS, even if we have already a lot of space heritage. As already mentioned by Christine, our portfolio for Marcus is really a really versatile and big one. So we have more than 20 experiments. So he will not only participate in the Swedish experiments that Christine was already describing, but he will also participate in our human research program. He will support investigations in the field of fluid physics, of material science, and technology demonstrations. And of course, what is very important for ESA and for SNSA, we will also have some educational activities. Our focus is usually on Earth applications, but also on technology and science that enable long-term space habitation and exploration. So I cannot give you an overview about all the 20 experiments that we are doing, so I will go only for 2. The first one is called Bone Health. So this one is from the human research projects we have. And it will look at the changes from Marcus' bone density after his 2-week stays in space. Especially, it will check how fast will his bones recover when he comes back on Earth. Because we have seen that in previous flights, or also on Earth, if you're in the hospital, and your bone loss will continue after your immobilization stopped. And this was very unexpected. So ESA did other experiments before in space, and we were expecting that the same will happen through the crew members in long-term missions. And we were very surprised to see that we cannot see this effect. So we had a lot of subjects, and only one subject was a shorter duration mission subject. And this was the only subject where we have seen the so-called post-re-entry bone loss. So we are now very excited to have again short duration mission subjects in our portfolio to measure this more. And the second activity that I would like to introduce is ANITA 2. So ANITA 2 is one of our technology demonstration. It's an analyzing interferometer for ambient air. So what we're doing with ANITA 2 is we sample the air on the station, and then we analyze it for trace contaminants. So we can recognize and quantify 33 trace gases with infrared light, and we can also see if there are any unknown gases, and then we can analyze those on ground as well and identify them. So this is part of our technology developments for space flight in LEO and for exploration. And on the ISS, ANITA 2 is a technology demonstrator, but on the gateway later, it will be a part of the nominal system. So this is a good example how the ISS can be a test bed for future exploration activities. So back to you, Alexis.
Thank you so much, Julia. And thank you everyone for your overview of experiments and research for the upcoming Ax-3 mission. We'll now open the floor to reporter questions. As a reminder, if you have a question, please use the raise your hand feature, or you may submit your question to the moderator using the Q&A function. To help keep us moving, please say your name, affiliation, and to whom you'd like to direct your question to. All right, we will begin. We will start with Gohan, Kirk, Torin.
Thanks so much, Alexis, for the opportunity. Gökhan from Turkish Space Agency, Anadolu, based in London. My question to Mr. Atash: what will be the general benefit that you're expecting from all these experiments that you will carry out over there? And considering that this year is the centenary of Turkish Republic as well, and what will be how the next generations will be reading this from the history books? Thank you.
Thank you, Gökhan, for the question. Let me explain this way. I can say that each experiment and studies reveals to other scientists new information to give them a more comprehensive picture of biological, chemical, and physical phenomenon. So I can briefly say that. So each experiment is for the benefits of Turkey and world, of course. So if I specifically mention about some benefits, I can say that our human research will help to understand the reaction of human body, and which other scientists already studying on. And then the other physical experiment will help the scientists to get some knowledge on dynamics of particles in hybrid propulsion system for more efficient combustion system. And the other experiment will support the life support system in closed life system. So this list can be increased. So briefly, I will answer like that. Thank you.
Thanks, Ömer. So now we have a question in the Q&A from Jonathan O Callahan with Aerospace America. The question is, there has been a suggestion that commercial spaceflight research needs a code of ethics to ensure science conducted in space is ethical and follows due scientific process. How is Axiom ensuring that science it conducts in space meets these goals, and is it working with any regulators on the matter? And I believe this one would be good for Lucy to answer.
Yes, thank you, Alexis. I'm happy to jump in on that fantastic question. So I'm actually really glad you asked this question, because I was recently a co-author on the paper that you actually quote in the question that you ask, which was published in Science, which was a policy conversation piece about specifically this question. So Axiom is extremely committed not only to the safety and the health and safety of all of our crew, but we strongly believe in upholding the most rigorous ethical principles for all of our research, whether that is animal, human, or otherwise. So we actually were co-authors, as I said, on that paper that recently came out in Science that outlined 4 foundational principles that we strongly believe are very important for research that will be conducted in space, in the commercial space in future. But at the moment, we are actually, everything we do is that is done on the ISS goes through the NASA institutional review boards and ethical review boards. So everything we do already is held accountable to the very highest ethical standards, and we plan to continue to hold all of our research accountable to those highest standards. And we look forward to working with the research community, with other commercial providers, with NASA, with any regulators as necessary, to continue to make sure that every company that is operating in the commercial space is also holding their researchers and conducting research that is to the highest ethical standards for the safety of all of our spaceflight participants in future.
Great. Thank you so much, Lucy, for that. Well, now we're going to call on Don Halduk.
My question is for Jana Studemeyer regarding the research. You've described some amazing research on like using stem cells, and I can just see this blossoming into incredible for the human population. I guess how long and to upscale some of these researches for general distribution, and will the proposed Axiom Space Station play a key role in this research?
Absolutely. Thanks for the question. And you're right, there's some amazing research that's going on across the entire portfolio, and specifically on the applications that we're working on for cancer and neurodegenerative diseases. You know, we intend to have those types of models available regularly on the Axiom Station, increasing the ability of discovery for not only understanding diseases, but also for accelerating drug development for new therapies. In addition to the in-space manufacturing work that we're doing to actually produce products on orbit, these types of models are very important in helping us to advance technologies and understand what it is that we need to develop for new therapies. When we think about the products that we can make on orbit that are different from the products that we can make on the ground, a lot of these types of models are helping us to understand what those products might look like. So we're very excited. The work is significant now, and it just will continue to pick up with the cadence of access to microgravity through things like private astronaut missions and a logistic chain that really supports commercialist activities.
Thank you.
Thank you, Jana. That's very insightful. We're now going to call in Marsha Melly.
Good afternoon. Thanks for the opportunity. I've got a question for Barbara Negri from the Italian Space Agency. I would like to know something more about the Orion experiment, about women fertility, and in specific, how it will be conducted, and which is the purpose of an experiment like this one in the future of human exploration and life in space, and if there are some university related to this experiment. Thanks very much.
We should understand that in the future, probably there will be permanent base on the moon or in the really far future on Mars. And it is important to understand now if there will be problems and countermeasures to investigate now for fertility in hostile environments as Moon or Mars. From the point of view of the experiment, there is a co-culture of two different bovine cells types inside of Orion experiment. One is granulosa and the other theca cells, which function together for the correct hormone production in the ovary. This culture will grow together for 7 days on board of ISS. We already did this experiment during the mission of Samantha Cristoforetti on ISS 1 year ago, and we have some data already collected. And this opportunity will give us, this flight will give us the opportunity to improve our database. But going back to the experiment, moreover cells will grow with and without myo-inositol, which is supposed to have a protective function on the hormone production in microgravity conditions. More or less, it's very important to understand the mechanism of fertilities and also have some data to apply all in Earth to improve the knowledge of the fertility mechanism in our planets.
Thank you. We now have another question in the chat from Just Unair with the Houston Business Journal. The question is directed to Lucy and Jana. With a diversity of experiments that are to be conducted during the mission, can you share any details on how mission perimeters might be different from previous Axiom Space missions to accommodate them?
Yes, that's a great question. Thank you, Alexis, and thank you, Jishnu. So as you point out, this is a hugely diverse portfolio of experiments, and we'll be excited to release more details about those as we get closer to launch. But we are incredibly lucky that we are working within the current NASA and International Space Station framework, and we're immensely grateful to the ISS National Lab to actually help us access those facilities and those resources. So in terms of how mission parameters are different, they're kind of not. They're going to be the same because, again, we have a really diverse range of experiments and we have an incredible range of facilities on the ISS that we're very, very lucky and grateful to be able to get access to. So we are also very indebted to our crew who work so hard to actually do the research. They perform the experiments, they work long hours, and they're extremely dedicated to the research. So we're very, very grateful to them. So in that sense, the mission parameters aren't changing for many of the experiments. Jana, I don't know if you have any flavor that you want to add to that question for relevance for the in-space manufacturing portion.
Sure. Thanks, Lucy. You know, as Lucy said, it is an incredibly diverse portfolio of science. And I think the opportunities that NASA, SpaceX, ISS National Lab, and our crew give us to accomplish the amount of science in these short missions is amazing. And it's a credit to everyone who is involved to be able to come out of these missions with such successful experimental results and opportunities to learn.
Great, thank you. So we have Bill Burrow, Swedish newspaper Ny Teknik, and I believe this question is for Christine Danenberg or for Julia Weiss. Question is about how the selection of the Swedish science project's missions for Marcus Want was done. Were they selected out of a larger group of suggestions from all ESA, or did Sweden have two separate slots? If Sweden had certain slots, how many suggestions were available and why were these two picked?
Yeah, thank you so much for this important question. So actually, as Marcus is ESA project astronaut, he will be doing a lot of ESA experiments, and most of them, or I would say all of them, are selected in open calls by ESA, and they are evaluated based on scientific merit, and most of them are already ongoing. But so as the Swedish experiments, so as you know, so it was the decision that Marcus would fly, it was taken just in this spring. So we didn't have really much time. So what was done, we issued a call for ideas for experiments that do not need any kind of considerable development of any new hardware, actually no new hardware at all, because time was too short initially. So Marcus' flight was foreseen in November. If you select experiment in May, you cannot build and qualify payload for a flight in November. But now it's in January, so it's slightly more time. But anyway, it was open call for ideas, and it was evaluated by Swedish National Space Agency and also members of its scientific advisory committee. And so one of the experiments, as I mentioned, it was already flown on sounding rocket from Esrange in Sweden. And actually it was selected by ESA for this suborbital flight. So scientific quality was already evaluated. And we also looked into this experiment an additional time. And then the second experiment, it was a new one, orbital architecture, as I mentioned, and it was, so evaluation was done by our scientific advisory committee. But then we didn't receive like responses, like 100 responses to this short call for ideas, very quick call for ideas, because the requirements were very strict, no major development of hardware or no heavy experiment. So this is how it was done. But it was kind of, it was a bit fast track, but it followed all our normal procedures as a scientific quality. And we selected ones that were feasible within this short time frame and had a high scientific quality. Thank you. Yeah, and Julia would like to add something about these experiments.
Yes, of course, we had the advantage that we have a lot of ongoing experiments on the station on ESA side that we could complement to the mission. But for example, this bone health experiment that I was just presenting, this was has been selected some years ago in an AO, and this was peer reviewed as mentioned by Christine. But of course, also here we needed to speed up really quickly now that we had the opportunity to add activities to a short duration mission. So we have a lot of things that are already ongoing, but as Christine said, we have also some new experiments that are flying for the first time.
Great, thank you so much. We now have a question from Pino De Feo from Italian press agency ASCE News. Is there a launch date, and are there other air forces besides the Italian Air Force interested in commercial space missions?
Yes, thank you. So for the time being, first of all, let me say that the Italian Air Force is celebrating this year 100 years of history, and we have been in the space sector in the last more than 50 years now. I would say that as long as Italian about air forces around the world, I don't think there are much air forces involved as air force, not with other organizations involved in the commercial space flight yet. I'm not sure. I don't want to say something I don't know about. I can get some more detail about that. But as long as I know today, the Italian Air Force is one of the first air forces participating to in this new era, under this new paradigm, where are not only the government organization participating to space flights, but there are government organizations working together with commercial entities to achieve the biggest results.
Thank you. We have a question from Dr. David Mariotta, who's the program director for in-space biomanufacturing at the ISS National Lab. Regarding the Ovarian Study, they are using cells not derived from humans. How are they planning to translate the findings into humans?
Experiment in space need to use some cells, not human cells, because it's not so easy to reproduce the real experiment in space using human being cells. The aims is to identify checkpoints and critical key points in the pathway involved in hormone production. By doing this, it will be easier to identify drugs able to act directly in these key points. Scientific experimentation needs some protocol that can be applied in a laboratory so different from Earth, like is the International Space Station. The next step, of course, is to translate these results in human cells, since Orion will study bovine cells. We can reproduce the data collected on space and give a comparison, prepare something's analog on Earth using human cell. It's very difficult to explain in deep which will be the scientific path for this experiment. But more or less, there is an experimentation on the ISS using bovine cell, but the data will be of interest of analog experiment on Earth using human cells.
Thank you so much. We now have time for one more question, and we're going to take this from Just New Nair from the Houston Business Journal. This question is directed to Lucy and Jana. From a Houston perspective, can you share how some of the research from this mission could return to our local healthcare ecosystem?
Yes, thanks, Alexis. So I think I'd like to point out that anything that is being done in space that benefits humans will benefit humans not just in Houston, but also all over the rest of the world. So we know that there's an incredibly strong healthcare network in Houston, and we are sure that much of the research that is being done will inform those researchers that are part of that research ecosystem in Houston. But really the research that we are supporting or that we are helping support through these Axiom missions is designed to benefit every human everywhere. Now, that said, we do see that a lot of the research portfolio that is coming through on Ax-3 is going to be advancing the understanding of things like neurodegenerative disorders, as Barbara was just talking about, learning a little bit more about fertility and trying to figure out how we can translate some of those findings from cow cells, for example, as the Orion experiment is looking at, to human cells. So we're really seeing that a lot of the research that is coming through is going to be benefiting healthcare systems down here on Earth by helping us understand various different aspects of aging or disease or fertility issues down here. But also a lot of the research that is being done to understand how humans adapt to space also really helps us understand our own physiology better. It helps us understand not only how we can adapt to space flight and stay in space for longer periods of time in future, but those findings can actually be translated back to improving clinical healthcare settings here on Earth. For example, in rural healthcare settings, helping people understand how we can adapt as humans to extreme environments, helping us understand how the aging processes might be informed by some of the research that we do in space. So there's lots and lots of things that we're doing in space that can help us understand and benefit humanity, not just in Houston, but all over the planet.
Thanks, Lucy. And I would just like to add to that, because, you know, what's interesting is that the science that we're doing on orbit, especially when it relates to human diseases, certainly the insights that are gained from the actual researchers who do that work on station, that's fantastic. But that insight is also infused into the science. And the science that we see is so different on the ground that it really helps to change the paradigm of how we look at things like cancer or neurodegenerative diseases. Those understandings are true innovation, and that's what will accelerate the breakthroughs in the field. So even if you're not participating in your own research on station, the research that's happening there actually has tremendous impact globally in terms of our understanding.
Thank you so much to everyone. You know, as you can see, that this is a very exciting time for the commercial space industry, excuse me. And as a reminder, the Ax-3 launch is targeted to launch no earlier than January 2024. If you have any follow-up questions, you can send them to media@axiomspace.com. You can follow updates on Ax-3 research and on our website at axiomspace.com and on social media. Thank you again for your time, and go Ax-3.